Hello everyone and welcome to a new Sega Mega Drive Genesis game dev tutorial. I'm recovering from a very bad cold this week, so forgive if my voice sounds a little bit husky, not quite so clear, but we'll soldier on and get on with the lesson. In the previous tutorial I introduced you to structs and how we could use those to help organize our enemies. While we did make good progress to that end, there were a couple of things which still needed doing, and in order to continue that in this lesson we're going to be using a different concept in C programming language called Enums. If you recall our struct from the previous lesson, you know that the first value in the array of structs was the status of the enemies. In the struct, this is represented by an unsigned 8-bit integer, so any value between 0 and 255, and each number will represent a different behavior. So 0 is simply not active in the game, and then 1 could be idle, and 2 could be attacking, and 3 could be, walking or running, and so on. While in theory we could as programmers memorize which number represents which behavior, this is not very readable, so it'd be better if we can do some writing instead to represent each behavior. One obvious way to do this, which we have done in previous lessons, is to simply use defines. So we could create two defined values, 0 and 1, and have it so that 0 is written as not active or inactive, and 1 could be, for example, idle, and then we could add more later, for example, attacking or hurt or dying or running and so on. And once these defines are already complete in the header file on the left hand side, we then go to our corresponding C file and replace the numbers with those defined values instead. However, if you ever find yourself having to write a list of related defined values, in this case the enemy behavior or states, it's normally better to just use something called enums. The way we define the enums in our header file is similar to how we do the structs. So you're going to write the word enum, then you're going to do a space, then you're going to give this enum a name, this list a name. And then after that you're going to do the open curly brackets and then make sure you put the semicolon after the final bracket. I've called mine enemy states here, but feel free to call it enemy behaviors or whatever you think makes sense. Next up, we need to go inside these brackets and actually start writing out the names of the list. So in a similar way to what we did with the define. So it's normally better to use capital letters. This is how it's normally done in C language. So just write a list of the each enemy behavior followed by a comma. While you can manually assign numbers to each of these enums by adding an equal sign then a number just with each one, if you just do it like this without writing a number, then it will simply start from 0, and then the second one will be 1, then the third one will be 2, and so on. And just as before, the 0 will represent inactive, so that in that case we don't want the program to create any of those enemies at the beginning of the level, and we don't want it to manage it either. And we're going to add a few more here. So you can see I've got enemy attack, enemy hurt, and enemy dying. So we can add more to these later, but for now that will do. With that done, we can now head back to the enemy.c file and we can replace those numbers at the very beginning of the array, the current enemies array, with these enums instead. So instead of 0, we can write enemy inactive, and instead of 1, we can write enemy idle. And of course, the enemies don't necessarily need to start off in the idle state. They might start off in like a walking state, or probably not a dying or attacking state, but they could start in many different states, but we'll just put idle for now. And just back in the enemies.h file on the left hand side, just to show you what I mentioned before, you can manually assign the numbers to these, but it's normally best just to leave it blank and let the enum automatically assign them from 0 to 1 to 2 to 3 and so on. And at this point it might be a good idea to save and compile and check the ROM to make sure everything's working okay, which it looks like it is. And just to double check everything's working okay, we can change some of the values here from enemy idle to inactive, and then the resulting, if we save and compile again, we should see that there are fewer enemies on the screen now. Okay, with that working okay, let's just change them back to idle now. And next up, we've already got it so that the current enemies arrays are looking a lot cleaner now. Rather than having these numbers, which you might not know what they mean, we now have the enemy status in writing, which is much easier to read. So we can now do the same for our create enemies and manage enemies function. So we can replace those numbers as 0 or the 1 with the actual enemy status. So instead of if it does not equal 0, we can say if it does not equal enemy inactive, then don't update the enemy and don't create the enemy in the first place. So now it's much easier to read. While we're not using what's called macros or defines for the enemy behaviors, we're using enums instead. One thing we can use the defines for is one-off values. For example, here the number of enemies we have in our array and the number of enemies we have the max enemies in the loop that we need to loop through. So instead of having this 10 number here, you can imagine if we changed it in one place, we'd have to then go ahead and change it in several other places too. It's a bit of a hassle. We may be adding more enemies, current enemies, than we've got at the moment in the future. So instead of doing that, instead of having a number each time we have to change, we can simply create a single define value. We can make it equal to 10, and then we can we give it a name, for example, the max number of current enemies on the screen or in the level, call it whatever you want, just make it very descriptive, make that equal to 10 as a regular macro or a regular define, and we can replace those 10 numbers both in the arrays and also in the loops with this macro instead with this define. Okay, so I think that's pretty much covered it. So now if we want to change this in future, we can simply change that single macro instead of having to go through all the code and change it all these different instances. And just a little extra tip while we're here, when you're doing lots of changes to a header file, normally it's a good idea to do a clean to make sure that the changes take effect, because sometimes they don't. So you can do a clean, then save, and then compile after that. So we've had a very busy last couple of lessons. We've introduced two new different C program concepts. So last lesson was the structs, which are I think a lot more complex than enums, but very, very useful in our program, not only for enemies, but also for lots of other things, as you'll see in the future. But enums, despite being very simple, are very useful too. Apart from enemy behavior, we're also in the future going to be creating enums for lots of different things. So for example, player animation. So we'd have an animated as kid sprite, and maybe in the sprite sheet, maybe the first row of the sprite sheet will be the idle animation. Instead of writing 0 there, we can substitute it for Alex kid idle, and one might be walking, and instead of having the one, we can do an enum like walking animation, and so they're going to become very useful. We're going to be using them quite a lot, and if you didn't understand fully, don't worry. For both the structs and also for enums in the next lesson, we're going to continue working on organizing our enemies so that in future when we add more enemies, more levels, it's going to be very easy. So we're putting in the hard work now, and so next lesson we're going to be doing another struct. We've created another struct and at least another enum too, so you'll be getting lots of new practice with these two new code programming concepts. So even if you don't 100% understand them now, don't worry, you will do after next lesson for sure. Okay, there's nothing left to do else to thank everyone for watching, and if you're interested in this type of content, don't forget to like and subscribe.
I'm interested in this.
And if you'd like to support my work further, as well as get access to a download link of the code used in today's lesson, then I put my Patreon in the video description below, and any support is much appreciated.
You won't go unrewarded.
Until next time,
farewell.